welcome. It's time for another power supply from Banggood. The SKU 215283, and this is based on the LM317 linear voltage regulator, a very normal kit. And the good thing is, in this kit everything is included. There's the, I'm gonna pack it up. There's transformer, there's the jack for the wall, there's a case and everything, and there is even a bit too much stuff. It seems like there are also instructions inside, so I'm gonna unpack it and we're gonna take a look at the different pieces. And we are unpacked, and let's start from the outside. Here is the case. I won't open it until I need it, and the wall connection, transformer, voltage display, heatsink for the main attraction, the LM317, PCB, transformer, all the components, and for some reason I have been given two 4069 is, yes, hex inverters. We're gonna talk about this in a while, and LEDs and everything, and sockets, and even, I was surprised, alligator clamps and wires to do the output voltage, so you don't have to do your own wiring on that side. So we're gonna take away the things we don't really need right now, and also instructions. Nice instruction in English, and going through explaining the components, the resistors, the colors, nice images explaining all the way how you're putting these together. So there's basically no questions, just follow the instructions. But there is three things in this one that sometimes confuses people. It's really nice explained in the event. There's a buzzer end. Input the high level buzzer, signal output, output square signal and change the output frequency by adjusting R5. Logic signal input. The red LED shines with high level inputs, the green LED shines with low level inputs. That's three nice things that are implemented on the PCB, but I don't want them. I am just here for the LM317. I have it blown up the circuit as much as I can. I hope you can see it. Up here you have a LM317 connection system, power supply. You have a transformer, 4 diodes, capacitors, the LM317 with protection diodes, the big potentiometer, that's also a knob to the big potentiometer where you adjust the voltage, and you have capacitors on the output and an indication LED. It happens to be a blue one. I'm going to check that if I want that LED and that resistor there. But then there's three more things. You have a buzzer system, the logic probe, and yeah, we can call it a square wave frequency output. They are based, the frequency output and the logic probe is based around these integrated circuits, which are 6 hex inverter. It's a hex inverter. There's 6 inverting gates inside. My little plan is to save down on the PCB, and it also saves me a bit of current, because all these components here are pulling current through the LM317 and this quite tiny transformer, which I don't think can take as much load as you might want. So my plan is to not mount this part or this part or the buzzer, and I'm also thinking I'm gonna save in on these 3 connections. So I'm just going to use these 2 here, which are power output. So I'm gonna also blown up the PCB layout. Is from the Banggood's homepage. So I'm gonna mark out what I do not want to mount. So this bag is the components I will not use. I'm not saying I don't need them, but I will not use them. But the thing is, I have more components left over. I'm trying to figure out if I've done something wrong, but I've checked the wiring diagram and everything twice now, so I think they have been nice enough to put in a bit too many components in the bag. But okay, things happen. Throw it away for later. And here's the PCB. So let's see if I can get my little schematics out here. There's even more I'm not using. The C6 will not be used. These are the components I will not mount. So they are mostly on the right side of the PCB here. If you can do it yourself, you can check the parts numbers. There's just one thing I noticed, that in the instructions there are some differentials on the value from the image on the production page, on the web page, but not that big difference. And if you're just working slow and following instruction, we should be able to put this one together. This is what the PCB looks now. I have mounted everything what I think I need. So the diodes on the input, big capacitor and the small capacitor for the input, small and big capacitor for the output, the LM317, the two protection diodes, the sensing resistor, which it's measuring its voltage over. There's 1K resistor up here, it's the one at the top, close to the capacitors, that's for the blue LED. And there's a small capacitor down here next to the big potentiometer, that's for reducing ripple and other things, and the two connections out. So there's no buzzer, no transistor, there's R6 and R4, potentiometer, capacitor, yellow, red and green, LEDs are not there, the two resistors down here, and the big hex inverter, the IC, is not here, and the 3. The only thing that's left now is the voltage display. And while you're doing your soldering, you will need 3 leads or legs from components, because this is not prepared for the PCB. Let's find the base plate. It should be a big piece, and how do we secure the transformer? It must be that one. There we are. And now, according to the instructions, I have checked with your instructions. The red leads are the main supply, and the blue leads are the 12 volt AC. The power supplies, or connection for the power supply, nicely enough, they have also supplied you with the kit with heat shrink tubes to protect the wires, so you do not get live voltage touching anywhere inside here. So everything mounted on the back plate and secured. So we're gonna power it up, and we have voltage. I don't want to touch anything live here. 1.16, that's the lowest, and I can right now turn it up to, I don't know if you can read display the blue LED, 14.8 volts. I'm going to try it with a load later when I have put all the things on. The blue LED is very bright. I think I'm going to keep it anyway. It reminds me that I have a power on, and it turns on off around 3 volts there, that's right. 2.7 volt is a minimum to maintain the LED. And the first one, 150 ohms. Let's see, I want to have something to protect if it gets hot, but does not short circuit everything. It's not warm yet. I'm going to put it like that. And we can turn it to 10.7 volts. We turn 150 ohm. We go do with math later. That's 10.7 volts. I'm going to turn it off again, and I'm going to hit it with another resistor. Not hot yet. So we had two 150 ohm resistors. Let's see, we have a good connection to the alligator clamps. That's it. Let's hit it again. And now we can do 8.6. And finally, a third resistor. That means we're gonna end up at a load of 50 ohms. Let's see, we can get them all three in there. Let's twist them together so you get a kind of connection. Something like that. I'm gonna hit it again, let's see. And we can turn it to 7.5 volts. Yeah, let's do the math. How warm everything is going to get under pressure a bit. I'm running it with 250 ohms resistors. That's the 75 ohm load and 7.5 volts or something like that. So I'm running 100 milliamps on the output. Here is the setup running for a while, and sorry for the panning. Just to get my FLIR in here. Let's see. We have the load, which is a nice almost 50 degrees. Yeah, I know my battery is going out in my thermal camera. And here is our power supply. Yeah, the transformer is hitting something like 35 degrees, not too scary. I remove a lid so we can look with the thermal camera, otherwise we will just get the reflections of the plastic. This is my hand. If you want to compare the temperature, that's my hand, and this is the components. And yeah, it's a bit hot here. That's the rectifier diodes. I don't know if I have the bad soldering or the copper plating is too thin, but there's nothing. And the LM317 is not even close to hot, so there's no problem. So I'm gonna turn this off. If we're gonna do this way I've done it, and you don't know which component am I supposed to not put in, there are basically three components you don't need. That's the big IC, the 4069. If you do not mount that, you get rid of the logic pen and the function generator, and you skip the transistor up on the right corner. Then you remove the buzzer function, and you do not need the connections, free connection plint, just the two. If you do that, you can mount everything else and it will be dead and not pulling any power from the supply. So this way I'm using it as only a power supply, no other functions. So you're gonna try it. Yeah, there's a link down below to the producer's page, and yeah, nice product. I don't remember the price, but it's very low for a complete power supply with a case. Not a high-end power supply, but something if you want to remove and try out your small builds and you don't want to waste batteries in big amounts, you can use this instead. Good luck!